Major support for Do the Math has been provided by Chevron, California Resources Corporation, Edison International, Center for Neural Skills, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, Tuolumne County Superintendent of Schools, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Cindy.
Hi, I'm Vedehi. For math homework help, call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net and on social media.
Do you follow us on social media? Do you follow us?
No.
That's okay.
Don't
I
use
don't
it.
either. I just let all the ladies take care of it and stuff like that, so that's fine. I would be surprised if you said yes. So, Vedehi, what school do you attend?
I go to Highgate Elementary.
And you're in 6th grade, correct?
Yeah, I'm in your gate class.
I know, and that's how I know you're in 6th grade. But last year, you were not on the show with me.
Yeah.
But you were on the show, which is how you received the shirt. So
Yeah.
what part of the show were you on last year?
I was in the science program.
You were in the science challenge, right? And you had a lot of fun with that, I take it?
Yeah.
Okay, well, yeah, so it's good that you had good fun with that. So what was your favorite part of that? I know you were talking to some of the girls before, but what was your favorite part of that science last year?
Dismantling pens. And
Dismantling
assembling.
pens. So when you go back home, do you take apart everything?
Not everything, but some pens, yes.
Okay, do you take anything else apart other than pens?
No, not really.
Not yet. I'm sure you will, right?
Yeah, maybe.
Okay, well, good. So how is 6th grade going? Everything cool so far?
Yeah, it's going good.
All right, good. Well, you know what? We're going to do a social media problem of the day.
Okay.
And it's going to be something that I don't think you've been introduced yet, but are you ready to try it with me?
Yes.
All right, let's take a look at it together. So it says simplify the expression. Now, you've done expressions where you combine like terms, okay? Now, we don't have to solve for anything because there's no equal sign in here. So we just have to simplify this as much as we can.
Okay.
And when we simplify things, we want to put like terms together. So first of all, do you see anything that could possibly go together?
4a minus and negative 3a.
All right, so you think the 4a and the minus 3a can go together. Why is that?
Because the a squared doesn't have any other a squareds. And there's 2a to the first powers. Basically, that's why.
But if I take two a's to the first power and I put them together, don't I have an a to the second power?
That's a multiplication. In addition, that's not how it works.
Okay, so you're all cool on this. I was just trying to throw you a curve there and see if I could trick you a little bit. So you can recognize that the a to the square, the second power, is different than the a by itself.
Yeah.
Okay, so now we need to put this thing together. Do we do anything with the 7? Can they be combined with anything else up there?
No, because there's no other constant, like individual variable without any a's.
Very good, all right. So nice use of the vocabulary also, all right. So we need to put them together, and if we did that, you said that 4a minus 3a we could put together. What would we get then? So if we had 4a minus 3a, what would we get?
A.
A. Positive or negative?
Positive.
Positive. So do any of those have a positive a?
Yes, A.
A does. Now what about b? That's positive. There's no negative symbol in front of it.
In B, it's not correct because, first of all, you're not supposed to, because there's nothing to divide the 5a by. If you, 5a squared by, because if you could divide it, then that's the only way you could possibly
Good,
get
and
that.
we'd have a more complicated problem then.
Yeah.
But we're not getting any division here. So what you want to do is when you put these things in order, you want to put them as far as what the squares are, right? The
Yeah.
exponents. So the first one is squared.
Yes.
So we're going to go 5a squared first because that's the highest power.
Yeah.
Then what would come next?
Positive A.
And what would come last?
Negative 7.
So you still think that A is the best answer?
Yes.
Now, if I take a look at this and I go 5a plus a, I could get 6a minus 7. So would C possibly be an answer?
Nope.
Why? That was a pretty
Because-
fast nope.
Because, first of all, a to the second power can't be put with a to the first power.
All right, I'm just trying to throw you a curve again, see if I can mess you up, but you're pretty adamant about that a to the second power being by itself.
Yes.
So you're sticking with a.
Yeah.
Let's take a look and see if indeed you are correct. There you go, nicely done. First problem, all set. That wasn't too bad, was it?
No.
All right. 636-4357 is the phone number. Don't forget, email dothemath@kern.org in case you have any math problems and you can't phone in on a Tuesday or Wednesday. We can always take a look at those online. Time now for today's Math in the News. And last week we did not have any live programming due to the Thanksgiving holiday, and everybody knows about Black Friday. We've spoken about Black Friday numerous times on Do the Math and what that means and how it works. Since we were a little bit younger, we had Cyber Mondays now come into play. So this is where people go online to do a lot of their shopping. And it creates more traffic online and more sales for the stores because then people don't have to go out and look for things. They can shop at their leisure. And a lot of times they do this at work, but that all depends upon where you work, whether or not you're able to do something like that. But what they do is they want to have a lot of discounts and sales on Cyber Monday to entice you to do this on Monday where they're counting on those sales as opposed to Black Friday sales and other sales where you're actually going out to the stores. So that's Cyber Monday. So a lot of deals, a lot of math because the old deals are going to have some numbers involved with it. So you need to understand how to properly calculate discounts so that way when you're comparison shopping you can take a look and go, all right, I can get this, whatever it might be, and a lot of times they're electronics, big priced items like that. And you might go, well, that one looks good, and that's the first one I saw, but then you might see something else, and it might be a different discount, but if it's a better deal, that's what you want to look at. So then we're going to take a look at the problem. You have $1,000. The price of a TV is $1,150. So obviously you don't have enough money for the TV. So you could wheel and deal a little bit, but most people are not going to be comfortable going into a store and wheeling and dealing. So they're going to say, can you buy the TV if you get a 10% discount? So the first thing we need to do is we need to take a look at a 10% discount. And I do believe I'm going to have to annotate on this, correct? I'm already going? All right, good. So we're going to take 1,150 and we're going to times that by 10%. Okay, we're going to take 10% of that. So we're simply going to take that and we're going to convert it to a decimal, which is 0.1. When we take 1,150 and we multiply it by 10%, we are going to get $115. Now, if we had $1,150 on the sale price and we're going to take $115 away from that, we can see when you borrow and take over and everything like that, we're going to have $35 that we're still going to need in order to get to that price. So if they go, the price is this, you've got $1,000, we'll give you 10%. You go, great, 10% helps me out, but I can't quite buy that. You still need $35 more in discount to do that. 10% wasn't enough. If you double that, you're going to have $230. That's way too much of a discount. It'd be great if you could get it for 20% off, but you just want to find out how much money do you need to have off in order to be able to afford the $1,000 TV. You need $35. If you just take a look at 35 and 115, if we round both of them, 35 is approximately equal to 40 if we round it. 115 is approximately equal to 120 if we round it. 40 out of 120 is a third of that. So if you take 3 more percent and we take 13% off of the 1150, that is going to be $149.50. You need $150 taken off so that you know if you have 13%, it's got to be a fractional part over that in order for you to afford the TV. So if they go, we'll give you 10% off, and you go, how about if we can do 15%? They go, we're not going to give you 15%. So that's when you start going back and forth, and you just want to get yourself a little over 13%. If not, you find another deal where you can have the 13% off the same price. That's the key. The 10% might work if it's a lower priced TV. But anyway, that is today's Math in the News, Cyber Monday, how discounts work a little bit. We'll be back with more right after this.
Today's installment of Meet a Mathematician. Really interesting guy, at least as far as I'm concerned. Isaac Newton. He lived in the 1600s, and they didn't have nearly as many medical advancements, and so he was born at a really rough time. In fact, while he ended up being a teacher at Cambridge University, the whole place shut down because of the bubonic plague. All kinds of stuff going on, but that did not thwart Newton from learning about math and using math and being able to do some things that helped all of us. Now, I know that not everyone is probably the biggest fan of calculus, but it really helps out our society quite a bit. He is known as the founder of calculus. He also, maybe something that you might know a little bit more about is gravitation. He developed the theory of gravitation, and he also taught a little bit about the nature of light, amongst all kinds of other things. But with all that stuff going around in his head, Newton was known to be a little bit absent-minded. But here's what he was thinking about. Sometimes he was thinking about, amongst the many, many things that he was able to show the world and discover, he really liked exponents. That was one of his things that he liked to talk about. And so one of the things that I like to do with my students to show about the nature of exponents, let's say that you challenge your parents, hey, give me a penny on the first day of the month and double it every day. I'll do all my chores, I'll do everything you ask me to do the whole month, and it won't hardly cost you anything at all. Or you can give me $1 million. And of course your parents are gonna say, well, of course I'll double it, because the second day is gonna be 2 cents, and the third day is gonna be 4 cents, and the fourth day is gonna be 8 cents. And the reason this is exponents, this is 2 to the 0, and 2 to the first, 2 to the second, and 2 to the third. So if you keep on going throughout the whole month, in fact, the first week you can see isn't a whole lot of money, but I would challenge you to keep on going, because you'll probably see about week 3, you're gonna pass $1 million. It's amazing, and you're gonna get even more after that. So the reason that that's important is because the power of exponents make numbers go up so much faster. And that's one of the things that Newton was interested in. So I hope you learned a little bit about Newton today. Really interesting guy. That's today's Mathematician of the Day.
Did you know that the square root sign, also known as the radical sign, was derived from the Latin term radix, which means root? No, this symbol was not used when giving root canals, but rather when you are figuring out the square root of a number. So you can stop worrying about your teeth in math class now, because this is a purely mathematical sign. Now you know.
Well, thanks to Sam for that. Now you know about the root and the radical symbol. Were you ever introduced to using radicals and square roots of things yet?
Yes, I was.
Can you tell us a little bit about what you know about those, kind of briefly?
Okay, so
Or an example?
radical roots are basically, if you have like a number, let's say 5 squared is 25.
Right.
If you put root 25, the answer is going to be 5, because 25 is 5 to the second power. And when you do square roots, at the same time, you also have root, and then also to the second power.
Nicely done. And cube roots and things like that too, right?
Yes.
So that'll be some stuff you get into later on. You ready to do your not your first one, because you already did one with me, but now you're going to do a more difficult problem with Cindy. Are you ready?
Yes.
All right, head on over to the board. All right, so Cindy, why don't you go ahead, read that. Vedehi, I want you to start thinking and telling Cindy how you want to start this problem, and you guys can go about it, all right?
Okay, fill in this
Sujiko.
Sujiko, I've never heard of it.
That's what we're gonna
Puzzle.
go with.
Use the numbers from 1 to 9 in the 9 squares. Each circled number must be the sum of the 4 squares surrounding it.
Okay.
All right.
Okay,
So we already have 7 and 5, so we have to work with all the other 1 through 9.
Okay, so my first step would be just to subtract 20 from 5, see what I have left.
Okay.
So 15. And then I can just think of any way that I can get 15 with 3 numbers. So let's say 6, 1, and 8.
Okay.
So we can put those numbers anywhere right now.
All right. So right now we know we have that one working.
Yeah.
Okay.
Then, no, that wouldn't work because that's too big. Because 6 is 8 is 14, add that 7, that's 21. So,
So
that's
you're
too
already above that one. Okay. So we know the 8 can't go there then, right?
Possible. I think a 6 can stay.
Okay.
You can put the 1 here and the 8.
All right.
Then add these numbers. So that's 14. No, that wouldn't work either.
Because you can't put 6 because you already have 6.
Yeah. So
All right. Want me to
it looks
do
like I have to move all 3 numbers. Let's see.
Well, it could also be different numbers too, right? We don't know for sure.
Yeah, just a
Okay.
guess. We can't put it in either of these 2 spots because either way it's not going to satisfy our condition. So we put 6 here. And let's try this.
Okay.
That's 16, so 4.
Okay.
So far, it's working out. I'm just going to write down the numbers on the side. So I can keep track of what I have available.
So you've used 4, 8, 6.
7
Yeah.
and 8, yeah. Okay, so I have these 3 numbers.
So we have, what do we have left? A 2, a 3, and a 9?
Yeah.
Okay.
7 plus 1 is 8. Subtract, that's 15. Well, there's no way to make 15 here, so that's most likely wrong.
So,
I like how you started with the 1, 6, and 8, but what I might try, and I don't even know if this is the answer, just flip the 1 and the 8 and see what happens.
We can try that.
So just
Oh.
you can just erase the 8 and the 1,
just like,
Oh, okay.
and just see how that works after you do that.
I see what Mr. Kushan's saying.
And make sure everything still works, but then it might be a little easier.
Well, that would still be 4.
Yeah.
Yeah.
Oh, yeah.
Because you didn't change the value of the
yeah.
addition right there.
Yeah.
You just made it to where you have something
Oh, wait,
bigger to
I
work with
didn't
down
switch
here.
it. No, wait, I did.
You did, yeah.
That's 8 remaining. You still can't make it.
Okay. Because you can't use the 8 again.
Yeah. So I think this part's wrong.
Okay.
Oh, shoot.
Which, probably makes that one, yeah, okay. Let's try this. Let's try a strategy where that's our biggest value.
Yeah.
And we have 9 as our biggest number. So let's try to see, like, if we work with the 9, and maybe I'm thinking these are both kind of big. Maybe the 9 would go there, but it would probably go in one of
Maybe we
those
could
2
try it.
spots. Let's try it. Let's try it.
That's 14. Subtract from 28, so that's 14 remaining.
Okay.
I'm going to rewrite these.
Okay, so 7, 5 are crossed out, and then 9 is what we've tried so far.
Yeah, we're going to leave it like that.
Okay.
We have 14, so we have 14 left. So we can make 14 with 8 and 6.
Okay.
I think the 8 being this biggest number can go like here somewhere,
Okay.
I think.
Sounds like
8
a good strategy.
and 6 right here.
All right. So we know that one works. Okay.
7,
What do we got over here? Ooh, I
that's,
think that's too big, huh?
yeah, that's too big. So most likely we can switch the 8 and the 6.
Sure. Assuming we got the 9 in the right spot, huh? We don't know yet. But we can try it, right? Okay, so now we have,
That's 22.
okay, so we just need the 1.
That fits.
Okay.
6, that's 11, so we need a 9. We have 2, 3, 4, and 7. So I think we can make it with 2
Well,
and
7 we've used.
No, wait, never mind. Okay, 7. We have 2,
So what do we have? 2, 3, and 4?
4, not 5, not 6, not 7, or an 8 and 9. So I don't think that's going to work out.
So you have 2, 3, and 4 left.
Yeah.
Right? So 2, 3,
But
and 4.
you can't make a
and
9 like that.
Oh, for this one?
Yeah.
Okay.
You're going to need to use all 3 of those numbers.
Okay. So maybe the 9 didn't go there then. Or is there any So you had 8 and 6, and yeah, that was pretty much your only option, huh, for what you needed still right here?
Maybe switch the 9 and 8.
Yeah, maybe put the 9.
Okay, let's try that. Oh wait, that's not gonna work.
Well, we would have to change, like, just,
Oh wait, actually, never mind.
no, isn't that what we had before? I think we need to put the 9
Oh,
there.
wait,
Right,
and
the
there.
9 in the corner.
Yeah, I think that's what we had. the
Try
first
that.
time.
So now the 1
Becomes a
become
2.
a,
2.
Okay.
there you go. Now you
So
have
now-
what left?
1, 3, and 4.
Okay, 1, 3, and 4. And you need to make, but you still need to make 9 right here though, huh?
Yeah. And,
And
so
you can't make 9 from 1, 3, and 4.
I
This
think
is
we
a fun problem, isn't it?
yeah.
It's kind of challenging.
I think we could try putting 9 in the middle.
Okay,
Wait.
you want to just, all right.
We could work with this one here. 14. Still need to make 14, so we can do 6 and 8.
Okay, but let's see, what this is 16
16.
right now, so we need
And-
7 more, so
6 will work there, and 8. So that'd be
so
1.
then that would be 1.
Then we have 2, 3,
So
4.
2, 3, and 4.
Yeah,
Okay.
but we can make it work.
So
Yeah, we
that's
can.
14.
We
and
can.
So
Wait, so if we put the 2 here, that's 18. No. If we put the 4 here, then that's already
what
20.
do we need here? We got 16. We need 4 more here.
And then we need 6 more here, so we can put 2 and 4. Either way,
Yeah, that's not going to work though, huh?
no matter where we put it, it's not gonna work.
So you're well on your way though. So you know
We're getting
what's not
closer. We're
working.
getting closer.
So, Vedehi, because you're doing some great work right now, you're going to continue working on this as we learn about one of the tools of mathematics. But because you're doing some great work right now, we're going to award you with some holiday lights at COM. So hopefully you have an opportunity to head out there with your family and enjoy that family tradition. Could be one of yours if you don't know it already. So congratulations on that. We'll be back with more right after this.
I'm John, and we're back in the Do the Math Hot Rod Garage talking about the tools of mathematics. Drag racing is nothing but mathematics in action. We use math throughout the entire design of our race car and in its construction. We use a ton of math when we assemble and reassemble the engines that go into our race cars. And one of the critical components that we check are the tightness of the fasteners. We've got 4 fasteners on this main cap, and they've got to be tightened to a specification that the manufacturer gives us. These have to be tightened to 95 foot-pounds. Foot-pounds is a measurement of torque, the torque on the bolt, the clamping force that this nut is exerting through the stud down into the engine block. And we've got a special wrench that is today's tool of mathematics. This is a special wrench called a torque wrench. It allows us to measure the clamping force as we apply the wrench. There's a graduated scale here in foot-pounds. We adjust the wrench to the desired foot-pounds. In this case, we're going to torque those main caps to 95 foot-pounds. We just turn the wrench. We're going to start at about 65 foot-pounds. So now we've matched the 5 above the 60 line that tells us that the wrench is now set for 65 pounds. The torque wrench will give us an indication, an audible click, when it's reached the setting. I can feel that in the handle, and you can hear it. I'll tighten all of our fasteners to 65 foot-pounds to get us started. A nice smooth pull on each fastener. We're doing this so that the fasteners on the cap tighten evenly. Now I'll adjust it up about 20 more foot-pounds. We'll take it to about 80 pounds. Again, the same procedure. I've rolled the handle, increased it up to 80 foot-pounds, and we'll go back and go through our 4 fasteners again. Hear that click? I can feel it in the handle as well. That tells me that these fasteners are now tightened to the specification 80 foot-pounds. Now we'll take it up to 90. We go in these increments so it's a nice even clamping force on our main cap. Notice that the fastener is not moving very far now. We're just adding a little bit of clamping force to it. Now we're going to take it that last 5 pounds. A simple movement of the wrench. We're at 95. Our 5 is just above the 90 line. This would be our final torque for these main caps. Didn't move much. Our main caps are now all torqued to 95. Torque wrench. There's another example of a tool of mathematics that we use in the Do the Math Hot Rod Garage.
Always fun in the Hot Rod Garage. Time now to take a look at another of the antiquities of math. You know, it seems like it's 100 years ago, the 1930s, 1940s, just with the music of the antiquities of math. And I saw you doing your little bopping right there, and I think we can all kind of sense that right there. How are you today, Ashleigh?
I'm doing well. How about yourself?
Excellent. You're with the Kern County Museum.
Yes, I'm the curator
And-
over there.
Right, so your role, curator.
Yeah, curator.
And how long have you been with the museum?
I would say about 2.5 years now.
All right. A lot of fun things going on at the museum.
Oh, yeah.
Always a lot of events going on.
Oh, yes.
A lot of different exhibits, and there are things that you guys kind of circulate every once in a while also.
Yeah. This weekend we have holiday lamplighters. That'll be fun. That's an event for the Christmas event. And I think we just opened, back in September, the Italian home.
Okay.
The
Yeah,
Italian
I was
Firehouse.
at that event, so
Yes.
that was a lot of fun out there. So this is Vedehi, Ashleigh.
Vedehi.
So young and old.
Yes.
So young and old. Everybody loves seeing a box, kind of figuring out what's in it.
Yes.
Right? Now, Vedehi, if you had to guess, what do you think could be in that box?
Can I lift it?
No.
Oh, okay. Maybe like some kind of machine, like something like computer-sized.
Okay. If I was looking at this and I was thinking about holiday times when I was growing up, and I'm sure some people in the back would think the same thing, this is like a shirt or pajamas in there or something. That's what you get in a box like that around the holiday time. But computer science, something like that would be a nice little option also. So should we take a look and see what's inside?
Sure.
All right. Oh, we're going to let Ashleigh do this because she's a professional. I don't even get to touch this stuff. So she's
this
got
way.
her gloves. And the reason why the gloves, and actually correct me if I'm mistaken, but we have oils on our fingers,
We do.
and we don't want things to contaminate the antiquities that we're going to be looking at.
Yeah, so what even you'll notice here, this paper is specifically acid-free paper, which is specifically to protect older items because acid obviously eats away at things. So if I'm okay to open this.
Indeed, the time has come.
The time has come.
All right, so looking at that right now, do you have any idea what this is or what it has to do with?
Morse code.
How do you know that already?
I saw it over here.
Well, that's called being observant. All right? So, yeah, so I'm like, all right, so
Yeah, it's got
So,
the international Morse
international
code right
code. So there you go. So nice observation there, Vedehi. So have you ever seen one of these work, or do you have an idea of how it works?
I don't know how it works. I think it might be something to type in Morse code, like you know how they like send messages to telegraph?
Right. So that's exactly it.
This is exactly what this is. This is a training telegraph kit from the 1920s or so. It has both receiving and transmitting pieces here. This is the original box that it came in.
So hold that up to the camera so people can see that. And about what year, because I don't know if it necessarily has a year on that, but we were talking about when that probably came out.
Yeah, so from everything, like our paperwork, it says it's about the 1920s era.
So after the First World War,
Yeah.
right, and telegraphs were in use.
Telegraphs were in use all the way back in the Civil War even.
Right,
but
because I mean, this thing's not new.
No.
But as far as a kit for a kid to have, that's when it would have been produced like that.
Yeah, absolutely.
Especially with pieces like this.
Yes, and that's not the only piece. This is one other piece. This is the wire that would have connected them.
Now that makes sense. You need the wire also, right?
So it's kind of a jumble of a mess because it is about 100 years old.
And was there a certain type of wire they needed to use?
I would assume metal because telegraphs work as an electric communication. Do I know what kind off the top of my head?
Well, the valuable copper wire, I'm sure. It
Yeah.
may not, but, you know, just like pennies used to be made of different materials than the zinc that they are now, probably the same thing with wires back then also. So, basically, how would this work? You would connect some of the wires to one?
Right, so a wire would connect one to the other, one would transmit, and it would be like a clicking sound. Short and long, obviously, which is how we get the dots and dashes.
Right.
And then the other one would receive it and mark it down.
And the other person would need to know
What that means,
and
yes.
understand Morse code in order to
Yes.
receive this correctly. Otherwise, they could be kind of guessing what's going on. And you want to be relatively fast with this because you want to be able to transmit and translate and cipher everything as it's coming through.
Right, yeah, absolutely. That's exactly right, yeah. It was much faster than your typical like letters by like pigeon or mail
Pony
carrier or
Express
something.
and stuff like that.
This was, you just had to have a wire at least connecting those 2 points.
Right.
And
So
had
you would
long-distance
have your
communication.
station, you would have your wire going up to the
Right.
telephone poles, right? Not,
So-
but transmit, right? And then it would go off to wherever different stations it was going to go to.
Exactly.
Have you ever heard of a Morse code message? Have you ever heard of any things that are kind of popular or have ever heard one being used?
No?
Have you ever heard the term SOS?
Yes.
And do you have any idea what that means or where that came from?
Actually, no.
Okay. So do you have a little history on that before I,
Go ahead.
well, save our ship,
Yeah.
right? That's one of them, right? There's a lot of different things that SOS stands for, but save our ship is the big one, right? So they would be like, hey, you know, save our ship, Mayday, we got all this stuff going on.
Right.
We need help. So, and I see that we have the code up on the screen over there. So Vedehi, do you want to take a look at that? And at first we have a dash and 2 dots. All right, that would be the first letter. Can you see what a dash and 2 dots would correspond with as far as the alphabet and numbers go? You can go right over if you want, it's easier to look at. So 1 dash and 2 dots.
Okay. Okay, that's D.
D, all right?
Are you okay if I write it down?
I don't know if you're going to be able to write on this or annotate it, but we're going to keep it together.
D.
So now we have 3 dashes.
D, that's D. Do.
Okay, so we can write on it. So we have do, all right, 1 dash.
T.
You want to write it up there?
Sure.
Now we have 4 dots.
H.
You're quick on this. You sure you didn't do Morse code before?
No.
Okay, so 1 dot.
E.
So we have do the.
I think this is math.
You think
That's-
it's math?
I'm still gonna check though.
Okay, well, here's an easy way you can check, right? What's the T and the H look like? A dash and 4 dots, right? We have a dash and 4 dots, so what are these 2 letters going to be?
T and H.
So that's an easy way where you can take what you've already figured it out and make it a lot easier on yourself, right? So do the,
Okay. That's M right here,
very good.
and that's an A.
So you're figuring it out pretty quickly using things that you find and deducing from what you've already got. So do the math, ooh.
Okay, so 2 dots is I. I'm guessing this is do the math is good.
Do the math is good?
I think.
Well, let's put your S in there and let's verify that that's an S first.
Yes, that's an S.
Do the math is good, isn't it?
Yeah.
You willing to bet on it though? What other things
No.
can you think of that have an ooh in the middle? Do the math is good. Do the math is food. Do the math is mood. Do the math is noon. Do the math is moon. Do the math is soon. Do the math is anything else you can think of with an ooh in it?
No.
Cool, brother. Right? Cool?
Okay.
Is do the math cool?
Yeah,
It is, but let's see,
Okay.
make sure if it does work.
I'm pretty sure. Yeah.
You better check it out and make sure it works. That works?
Yep.
All right, so come on over here. Nicely done. So you were able to figure out that Morse code message, and I'm sure with a little bit of practice, you'd be able to do it a lot quicker.
Yeah.
And you have to be able to do it quickly when you're listening to it coming over. So have you ever done a Morse code message?
I have never done one personally, but I mean, obviously, we watch more movies growing up.
Now
with
you've got the
documentaries.
gloves on. You want to just tap out a little,
Let's see.
a dot and a dash. There you go. Right?
And I think with this particular one, you usually had to do the dots pretty quick.
Because there's got to be a distinctive pause or not in between these. So you want to make sure that it is a dit or a dot or a dash, things
Yep.
like that. Short, long, there's a lot of different terms that people use for those things like that. Well, Ashleigh, we certainly do appreciate you bringing us in from the Kern County Museum. I know there's a lot of things going on at the Kern County Museum. The website, in case people want to find out a little more, come visit you?
Yeah, absolutely. The website usually has all of our calendar and event dates, and then also if you follow us on Instagram or Facebook, we have a really awesome social media person who manages that.
Very good. So, Vedehi, if you were able to get something like this as a gift for a birthday or a holiday or something like that, do you think this would be something pretty neat to have?
Yeah, it sounds really cool. But a quick question before we go.
Yeah.
Why is there some letters missing?
Well, let's see. No, I don't. Let's see. There should be, I believe, 26 to 27 letters in the International
'Cause
Code.
the letters are in order, so just wondering why.
That's a good question.
It is, and it's something that you guys can investigate in just a moment because we'll be back with more right after this.
How do spacecraft slow down? Well, there are primarily two methods of thought for how spacecraft slow down, and you really have to ask yourself, are we landing in an area that has an atmosphere? If not, you definitely want to go with retropropulsion, where you use retro thrusters pointed down at the surface of the planet to slow yourself down as you're coming in. If you do have an atmosphere, it makes it a lot easier as the atmosphere acts as kind of a giant brake as you slow down. So you have your missions like Apollo that used retropropulsion when we went to the moon. When you're able to use the atmosphere, you have your heat shield on the blunt end of your spacecraft coming into the atmosphere, and then the parachutes will come out and slow you down the rest of the way to provide that safe landing. Here at NASA, we're constantly developing new technologies to help with that entry, descent, and landing, or EDL. Some of the trick in entering atmosphere is when you do have it, but it's really thin. One of the technologies NASA is developing to handle those is called HIAD, Hypersonic Inflatable Aerodynamic Decelerator. The HIAD can come as a heat shield much like the blunt body heat shields of those older missions that were made out of ceramics or metals and were very hard. However, HIAD is a flexible woven system that compacts really, really small. So you're able to actually get a very small heat shield inside your rocket diameter. With HIAD, when the fairing comes off, the heat shield can then inflate and expand to a diameter much larger than your rocket. Therefore, you're able to bring in a much larger payload than you were before. So how do spacecraft slow down? You have retropropulsion, you've got your rigid aeroshells and parachutes, and coming soon, we've got these inflatable heat shields.
In studio, we have Vedehi, a 6th grade student from Highgate Elementary. That's pretty cool with the telegraph Morse code machine and stuff like that, right?
Yeah.
Yeah. Well, now you know what SOS means too. If you hear that someday, right? People, if you hear somebody go SOS, they need help, basically, is what it is.
Yeah.
And it's all right to need help because you're going to need some help on this next math problem. Are you ready for that?
Yes.
So you know what Struggly is because you know that we
Yeah.
do it in class. And Struggly is a beautiful program because it doesn't tell you anything that you need to do. You have to figure it out on your own.
Yeah.
So this is one that I do not believe that you have tried yet. So why don't you head on over there with Cindy and see if you girls can figure out what you need to do with these dominoes.
Okay. So we got
All I-
3 places, looks like,
All I know
fill
is
in.
a 3-digit number.
Well, and then this says 10. I don't know if that means anything.
Maybe that means 10 tries.
Maybe. I don't know. You've probably worked with this program more than me. I've only done it a few times on here. Okay, so what do you want to do?
I'm gonna
Just try something, right?
Yeah, I'm gonna try adding them up first.
All right.
Because I know subtracting won't work or dividing.
Okay. Do you, are you adding them all?
Yeah.
Oh, how come? I'm just curious. I know, I just messed you up, huh? Okay, let's just throw some things in there and see what it does. Just so we're, have a starting point. Like put some, you probably have to slide them in there, you think?
How do you do that? Maybe.
Let's try it. Okay.
I think I get. Oh, I think I get what you need to do. I think you need to form this number
Okay.
on here using these digits available.
Okay. All right.
Just a guess. Let's see how it works. No, 5. Let's see.
Oh, okay. Those two ends are not the same color. Oh, you have to
I
match
get it.
colors. Can you turn it? I wonder.
This has to.
Yeah, put that one there and that one there. Oh no, it'd still be not.
If you hold the blue over a different square within the same domino, it will rotate. Just move the dot over one. There you go.
Oh, okay.
That works.
That's how you flip it. Okay.
That's
A mistake. Think correctly.
the
To
goal.
make the sum of your dominoes match the goal number. Okay.
So
Oh, because yeah.
I actually didn't. I did not notice that.
So we have 5 so far.
We could try moving this.
Okay.
Let's try 6. So basically there must be 2 numbers right next to each other. 2 plus 2 is 4, and 5 that's 9. No. Actually, I'm gonna stick with that here.
Okay.
And
I'm trying to make 10.
4. If we could, that was a 2. We could make that 4.
Right, right. Well, okay. And they have to match colors, right? So that's part of it. Because I was going to say, these would add to 10, but they don't match colors. Okay.
Let's move
Let's see
that.
what else we got here. Ooh, what about that one and that one?
Oh wait, I see it. Oh shoot.
Oh, it has to also match.
You're on the right track, though.
Goodness. Okay.
So you had the 6 and 2 up at the top, and then you had the blank and the 2 at the very bottom,
I
right?
know. We can put that first, because then the blank will match the blank. No, I mean that
Well,
one.
you can leave your
Yeah. So what I mean
blank
is
one up there.
we
Oh,
can
wait,
match
I
the
can.
blank. Yeah, yeah, yeah. There we go. There we go. Okay.
There.
Now verify. Okay.
All right, so good. Now you've got the 10, and you kind of see how it goes, right?
Let's see what's
All
going
right,
on.
try another one.
All right, got to
8.
make 8. All right.
We need a 2 and then a 6.
Well,
That could
5
work.
and a 3 or a
Oh wait, I got
4
it.
and a 4.
And come on.
All right. You're quick on that one.
Now you're on a roll now, right?
Yeah,
All
now
right,
you
so
got
let's see
it,
if you
huh?
can get one more done.
All right, let's see. What do we got now? 9. All right.
6 and 3 now.
6 and 3, 5 and 4,
Oh wait, 6 and 4 can work.
7 and 2. If there was
Wait.
a 6 was a 1. I don't see that.
2 and 4, 6. If there was a 2 and 1 for 3, then that would work. Actually, let's try this. No, shoot. This. Then this.
Okay, so
That
we got
makes-
3 so far.
And then.
All right. There we go. Nice. Got it.
All
got
right,
it.
there you go. Nicely done. So come on over here. So you got the hang of that. And the beautiful thing about Struggly is that it doesn't give you any directions. It just said start and then 10. And for a little while, you were kind of like, all right,
What are we
I can
doing?
get 10,
Yeah.
but it's not working out the way it has to as far as the dominoes go, right? And I noticed that what you wanted to do was start with the blanks. And why was that? Was there a strategy with that, or you just wanted to try it first to see how it goes?
I wanted to do it because I thought maybe if there was a starter with a blank, then you could find some way to format out.
Right, and 10's not a very large number, so it was probably easier to get to 10 instead of having a lot of different numbers.
Yeah.
Try to do that all together. So I know there was another problem that you were working on with Cindy, so you want to go back to that one again real quick?
Sure.
Head over to the board. All right, keep it going.
Oh, we still got our numbers in there and everything. All right. Because we were so close and we had to stop. Okay. So we need, it looks like 6.
1, 6, and 9.
1, 6, and 9.
Okay. That's 13. I'm thinking put.
Down one so we don't forget.
I'm thinking put the 9 here.
Okay.
13 plus 9 is 22. Let's just make sure that works here. That's 24. 6 goes
11
here.
then.
We're gonna go with that. 19. 19 plus 9. I think we got it. No. We're close though.
No, we're close, right? Because we got,
We're off by 1.
we have 22 right there. Okay. Let's see, what could we do? What if, no, because that would mess that up. I was gonna say we could put the 9 here and the 8 there, and then that would make one more here.
Oh wait, we already did this addition method with the 8 and the 6. That's why it's not working.
Well, but we might have had the other numbers in a totally different spot at one point, right?
I think we could try something else here.
Okay.
What if we put the 1 here? Or something, I guess. That's 14.
14, there's no way to get the
There's no 1
28,
there.
yeah.
The 1 has to go in one of these 2 sections.
Okay, so let's see.
If we made this 16, then we need a 7. That's already
That
there.
7's already there, so that can't be the,
So I'm pretty sure that none of the numbers can go in any of the spots down there.
okay, so then we have to change something up top then.
Yeah. Maybe we can remove the 8 or something,
Yeah.
I guess. No, wait, that's the only option for these 2, so you have to move something in the top.
Well, unless you change, what if you put the 9 there and then flip those 2?
I don't think that's going to change much because if flipping these 2 is not going to change anything much. Well, except that, but actually,
Because you
wait.
made that one bigger, so you make
oh,
that
wait.
one smaller.
Oh
You
wait,
see what
I
mean?
get. Yeah, I get what you
Okay.
mean. No, wait, never mind.
So this would be the 3.
That's 2.
That would be the 2. Okay. I don't know, let's see if that could work. So does it work so far? So 18, 19, 20, yeah.
Nope. That's
Oh.
11. That's 10.
That's 10.
If you put 9 here. Oh wait, because it won't make any difference in this section.
I bet if you had a little telegraph machine, you could Morse code SOS right now, right? You need a little bit of help. We're going to let you ladies keep on working on that. We'll be back with more right after this. All right, those dots and dashes, they're working it up right there. So you know what? You girls are still on a roll with this problem, all right? And you were just talking about with the 5 over there and the 28, you know you need 3 numbers that add up to 23. There are only a certain bunch of numbers that will add up to 23 no matter what way you do it, right? So head on over to the board and you guys keep on working on this. I'll give you a few more minutes, all right? Keep going.
Okay, let's see. So
I think we should solve for. We should find a bunch of methods and then try each of them.
you know what we could also do? Start writing things in the corners. Like, you know, have you ever done Sudoku?
Oh yeah.
You like use the corners so you figure out the right number?
Yeah.
So we don't have to keep erasing all the time? Okay, what do you want to try? Because I mean, like this does add to 28.
That works.
This
This
is 23. It's
those two work.
that's not going to work,
All
right?
the numbers we need are
Oops.
2,
Oh, whatever.
3.
Okay, 2, 3, 4. 2, 3, 4.
Oh, we
Okay,
already
so right now
tried
we have
this.
14.
In this scenario, we can't have any of them.
So we'd have to do 2 and 6, and then we'd have a 3.
It looks like we can keep. Let's just keep the 9.
So close.
Let's keep the 9, but change this bottom row.
Okay, what are you gonna change about it? Because it still has to add, these would still have to add to 14, whatever you put here. So, but you're right. I mean, is there a different way to make 14? 6 and 8, 9 and 5, but 9 and 5 is already taken.
I mean, there are other ways. Like, we already have the 5, so we can use a 9, but that's already used. 6 and 8's like the only way you can make 14.
Right, with what's left. Okay. So if we use the 9 here, we have to use the 6 and 8. So somewhere we're going to have those 3 numbers, right? So maybe it's the arrangement of the 3 numbers?
But that's if we use the 9, so
Right.
we don't have to use
No, I know. I'm just saying if we use the 9.
We could try it. Actually, we already tried dearranging it, like finding other ways to arrange it. That did not work. So I think we should remove one of these 4 numbers and replace it with something else.
Okay.
I mean, either way, if you remove any of these bottom numbers, you have to keep, there's no possible way to remove these 3 numbers. You can remove the 9 and move it somewhere else. And that would mean you have to remove these numbers as well.
Right. So if you're going to put the 9 somewhere, where do you want to put it?
Let's go for somewhere in this middle column.
Okay. Do you want to try it up here?
Sure.
I don't think we really tried it up here. Let's put it in the corner and we'll just we'll just try some different things. Okay, so if we put the 9 there, then this is 16, so these 2 would have to add to 4. So 1 and 3.
1 and 3 is the only way.
Okay, so probably the 3 there, I'm thinking, because it's, okay, so
12,
that would make
17.
that work,
No, that would make that work, not that.
but not that side.
So
Well,
swap it.
okay.
Oh, shoot.
All right,
Let's try the 3 and 1 instead.
okay.
That's 10, 15, so we need another 5. Yeah, 9's not gonna go up there.
Okay, so you know the 9 cannot stay up in the middle.
Yeah.
All right.
So then it
No
goes.
matter how it works, you can't, because you still need that 23 and those 3 at the bottom.
But if we had it like this, it didn't work? Did we try it like that before? With a 1 and a 3?
I mean, it's not gonna really change much.
That's what, we had 1 and 3 and 4, I think, up there or something, or no,
It's not gonna really change much because this is gonna be the same scenario. We're gonna reach the same scenario.
because that's still,
Since I think we already tried it here, so we can put it in one of these 2 bottom corners because I know it's not gonna go in the top one.
where do you want to put the 9? Oh, I
Let's
guess,
put it here.
okay,
Oh shoot, that's
9?
not good
Okay, so
Yeah,
9
that's
there, so 9 there, and then
because it's the biggest number.
that's 14,
We only have one way to make it.
right? I feel like we already tried these.
Yeah, so I think we should put the 9 somewhere else. We should put the 9 over there.
Okay. So that's 16, so we need 7 more, so 4 and 3,
Yeah, yeah.
because that's our only way, right? Okay, so
9, 12, nope.
that won't work. I feel like the 9 has to be here, and we're just not getting the other numbers right.
Well, if we put the 9 in any of these 3 boxes, we're gonna have to use 6 and 8. But we know that's wrong.
Unless we just, I don't know.
Then maybe it'll go in one of these two corners then, because that's the only option. Because we already tried these spots, didn't work.
I know, I'm just wondering if we missed something. Okay,
Let's try putting it here.
all right. Didn't try it there yet,
No,
the 9? Okay, so we got 14 so far.
14, so we need 6.
Mm-hmm.
That's really not too hard to make.
2 and 4. Okay, but then this is only 9, and we can't make 28 with what's left, right? Well, what's left? 8 is left,
Never mind, yeah.
and
Let's do the other corner.
6 is left, but those are the only big numbers.
Let's do the other corner then.
All right.
16, so 4.
So 3 and 1.
3 and 1, so no. Oh wait, we already tried it there, I think.
I feel like this can't be a small number because of this being so big.
Right, so I'm really thinking you're gonna need that 9 down in the bottom with that 28.
Well,
'Cause I
then,
know you're trying
Okay.
in different spots.
We're just gonna try it right there. I
Right.
know we've tried
So
it, but let's
anyway,
just try it again.
come on over here for a second.
He's gonna-
Vedehi.
He already knows the answer, I bet.
So what I'm gonna have you do is, because this is gonna be put up on social media, all right? Because there's gonna be a lot of people that are trying this at home also going, hey, try this, or screaming at the TV like that. You can actually hear them, right? And they're trying different things, just like with our social media problem of the day. So you're gonna try it out also, all right?
Okay.
So you can try it out at home, and you can bring it into class sometime. You can send it to us at Do the Math, and what we'll do is we'll have a little something ready for you for when you show us one of the ways that you can solve that problem. Sound good?
okay.
All right. So did you learn a little something today?
Yeah,
You did. And did you have fun today?
yes.
You know where else a lot of people have fun is at parades. Have you ever been to a parade?
I've been to the Disneyland parades, but other than that,
You've been what?
you know the Disneyland parades?
So you've been down there to see that?
Yes.
Well, that's pretty fun. Did you know that there's a parade going on here Thursday night in Bakersfield?
No.
There is, and the map route is right up there on the screen right now. So that is the Bakersfield Christmas Parade, and that is coming up this Thursday, December 4th, and it's probably going to start right around 6 o'clock, I would imagine, and it's probably going to go for a couple of hours, but you can see where the route is going to be, so if you're going to go downtown and you want to check out the parade, you'll kind of see where you can park, where you can drive to, and where you cannot. But anyway, it's usually a lot of fun. A lot of people like to go there and have a lot of fun. So hopefully you have a lot of fun if you are able to go to the parade. If not, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, California Resources Corporation, Edison International, Center for Neural Skills, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, Tuolumne County Superintendent of Schools, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education.